All right, guys, we are doing 10.6 today, which is translating conic sections. This is your last section of chapter 10, and then we just have one chapter left after that. So we're going to start with ellipses that no longer have a center at 0, 0. So now the center for this ellipse is going to be at HK. So first of all, the equation for this is going to look like this. It kind of has a circle feel to it because it's x minus h squared over a squared plus, and then this is going to be y minus k squared over b squared. So that top portion looks kind of circle-esque, right? X minus h squared plus y minus k squared equals r squared is the circle formula. This is for an ellipse with a center of HK. So we're still going to have a length of A and a length of B. And A is still going to be, when you're going left and right, from your center. And before it was always from the origin, but this isn't going to be the origin anymore. So it's from the center, and that's where a lot of mistakes get made. It's not necessarily the origin. It's the center of the ellipse. How far did you move A units to the left and A units to the right? Okay. And again, you're still going to have a B value, what we have right here. But now this one is going to be how far up and down you went from the center. Okay, again, your center not being the origin anymore, so just be careful with that. Okay, so what we're going to do is we are going to look at this first problem and kind of lay out what we know from this. First thing you can do is find the center pretty quickly here. So your center, if this is your equation, it's always the opposite of what it looks like here, right? Because we're subtracting the value, so it's x minus whatever your h value is. So h is actually going to be a positive 3, and y, your y value here is going to be a negative 2. So the center of our ellipse is 3, negative 2. So I'm going to go ahead and plot that. So 3, negative 2 is going to give me a center right there. Okay. Then we need to find our vertices. And your vertices are going to be on your major axis. And the way we can determine what our major axis is going to be, if you look here, this is 5 squared, right? That's your A value squared. So that means we are going 5 units left and 5 units right. This, let's pick a different color here. This one, the 16, that's up and down. And you got to think of 16 as 4 squared. So your B value is 4. So we're going 4 units up and 4 units down. So if I plot those, 5 units left and right, 1, 2, 3, 4, 5. Again, this is from your center. Okay, so 5 to the left, 1, 2, 3, 4, 5 to the right is going to put me at those 2 points. And then your other one, 4 up and 4 down, 1, 2, 3, 4, and 1, 2, 3, 4. Keeping in mind that your vertices are on the major axis. Okay, so this is going to be, let's switch to the color I'm using for this, on the major axis. And the major axis is always the longer one. So if you look at this setup, if we were to draw this ellipse, okay, my major axis is this one, right? So my, I don't know if you're going to still see that. I just undid it, but it's the horizontal, okay? My vertices then are these 2 points. So that would be the points 8, negative 2. And these problems, guys, are so much easier on graph paper, so I highly recommend you do this on like grid paper and Notability, or get some graph paper to lay this out. Your other vertex is at the point negative 2, negative 2. Okay, so those are our vertices, those blue. The covertices are the green. So here and here. And those are the points. And this is on your minor axis, right? Your covertices will always be on the minor or the shorter axis. So your covertices here are the points 3, 2, and 3, -6 would be this guy down here. So 3, -6, that's our covertices, the green. Okay, so then we need the major axis length, and that would be this length here, and you can just count that, like you can just check on your graph. We know we went 5 units to the left and 5 units to the right, so you're doubling your A value, or just count it. That would be a length of 10. Okay, your minor axis length, that's this one, and we know we went 4 up and 4 down, so double that 4, you get 8. And then last step, we need to find the foci. And this is, remember when we're doing a problem where we are adding like this, okay? For every ellipse, it's addition up there. That means for the foci equation, it's subtraction. So it's going to be c squared equals either a squared minus b squared or b squared minus a squared. But really what you need to remember is it's the bigger minus the smaller. So if you look up here, this is a squared, this is b squared. We're just subtracting them. 25 minus 16 gets you c squared equals 9, okay? Which means if we take the square root of that, c has a length of 3. Now here's where you have to be a little bit careful. We're not at 0, 0 anymore. So you can't just go, oh, it's 0, 3 and 0, -3, or 3, 0 and -3, 0. It's not going to work that way anymore. You have to do it from your vertex, okay, so, or from your center, sorry. And then you need to figure out what direction we're going. We want to go on the major axis, so we don't want to go up and down right now. We want to go left and right now. So if I go 3 to the left, 1, 2, 3, I get that point right there. If I go 3 to the right, 1, 2, 3, I get that point right there. So our foci are the points 0, -2, and 6, -2. Okay? All right, let's try another one. This one, again, you can find your center right away, just looking at what we have here. Our center is going to be using this and using this, okay? And it's always opposite of what it looks like. So this is going to be -1, +4 is our center. So -1, 4 puts us right there. Okay, so that's the center of our ellipse. And then we need to figure out our vertices and our covertices. And if you look at these numbers, you have a 4 here and you have a 9 here. Okay, that means that we are going for the 4, we're taking the square root of that, right? That's 2, and that's our x, so we're going left and right 2. And then for the 9, that's our y, it's with our y here, right? So that one's going up and down 3. So you're just taking the square root of them and then plotting them. So left 2 and right 2 is going to give me those 2 points, and then up 3, 1, 2, 3, and down 3, 1, 2, 3. It's going to give me those points. So our graph, I'm going to try and do this in a color so that it doesn't cover up my points so much. The ellipse would look something like this. We have to figure out the vertices. Now, the vertices are on the major axis. So my vertices are the green dots right now, right? The ones that went further. So these 2 points would be my vertices, which are the points -1, 1, and -1, 7. Okay, those are my vertices. My covertices are the blue dots right now. So that's going to be -3, 4. and go the other way, 1, 4. Okay, so those are my co-vertices. And then I check length. So my major axis length, remember that one goes with the green. So my length there, 1, 2, 3, and 1, 2, 3. So 3 and 3 is 6. And then my minor axis length, that goes with my co-vertices, is 2 and 2, or the distances we went, so a total of 4. So that's our minor axis. And then the foci, this is the one everyone loves the most, right? What you're doing with this is you are using your foci equation. So it's going to be c squared equals, and we're subtracting bigger minus smaller. So come back up here. You had 4 and you had 9. So we're going to go 9 minus 4, okay? So we get c squared equals 5. If we square root that, we get that c is plus or minus rad 5, or root 5, however you want to think of it. So then your job is to figure out, okay, where are my foci going to be? Well, if I'm looking at my ellipse, my foci are going to be on the major axis somewhere, right? So that means from my center, remember our center was -1, 4, from the center, okay, right here, I need to go up rad 5 and I need to go down rad 5. That's going to change my x value or my y value. It's going to change my y value, right? So my x value of my center is going to stay the same, -1. My y value is going to take what it was, the 4, and go plus or minus rad 5. And that will be my foci. So yeah, you can write it as this, or if you want to write it as the two separate points, it would be -1, 4 plus rad 5, and -1, 4 minus rad 5. I don't care if you write it like this or like that. Okay? Okay, that's the first two. Third one switches it up a little bit. This one says, write the equation for the ellipse, so we're still working with ellipses here, given vertices at 2, 5 and 2, -5, and co-vertices at 0, 0 and 4, 0. So if we plot this, vertices at 2, 5 and 2, -5. So 2, 1, 2, 3, 4, 5, and 2, -5, 1, 2, 3, 4, 5. You should be able to tell me your center right now, and I will come back to that, but you should be able to see it. Think maybe you can name it for yourself real quick. Co-vertices are at 0, 0 and 4, 0, and this makes it even easier to name your center now. So your ellipse looks something like this. Oof, that's bad. Something like that. Your center would be the middle of your two vertices or your two co-vertices. So my center is going to be right there. Okay. So name that point. Your center is 2, 0. Okay. Okay, so now let's put it in the form of our equation. We would say it's x minus your h value, which is 2 squared, over something, and then ellipses are always plus, and then it's y minus 0 squared, so you can just call that y squared. If you put the 0 in, it's not wrong, it's just simpler this way. And we set that equal to 1. Okay, and now we need to know what a squared and b squared are. And your a squared always goes the distance from the center to the left and right, either vertices or co-vertices. In this case, your co-vertices. So that's a length of 2, right? So we're going to take a 2 and square it for this bottom number. So this is going to be 4. Let's just write it in that same blue. Okay. And then for your y, we went up and down. This is 1, 2, 3, 4, 5. So we are taking that b value and squaring it. So that's going to be 5 squared, or 25 will be the number that goes there. And that's it. That is your equation. So those ones are a little simpler, I would say, not quite so many details you have to work through. Okay, number 4. This one, they give you a focus, and they give you the vertices. So it says write the equation for an ellipse with vertices at -1, 4. So go ahead and plot that. -1, 1, 2, 3, 4. And 7, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Okay. So those are our vertices. And then a focus at 1, 4. And before we draw the focus in, let's just figure out the center right now. So your center is going to be right in the middle of this. If you think about it, the distance from here to here is 8 units, right? From -1 to a +7, that's 8 units long. So you need to go 4. 1, 2, 3, 4 will put you right in the middle. Oh, it's like a little happy face. So I'm going to take this guy out of here. And I just took my dots away. So our center is the point 3, 4. Okay, so we do need to find the center. That's going to help us lay out the equation. So let's just start with that first of all. Let's lay this out what we know it would be. It would be x minus 3 squared over something. And then it's an ellipse, so we're adding plus, and then it's y minus 4 squared over something equals 1. Okay, now they tell us that the focus is at 1, 4. So 1, 1, 2, 3, 4. So this is going to be one of our foci, which means our ellipse looks something like this, okay? And we are trying to figure out a squared and b squared, and we know one of them. The one that we know, if you look at this setup, a always goes from center to vertex, okay, that length right there, and that is a length of 4. Right? That's 1, 2, 3, 4 units. So a squared would be 4 squared, or 16. Okay, so that's going to go under our x because that's our left and right. And then we need our b, but we don't know b. What we do know is that we have a focus, and from the center, that focus has a length of 2. Remember what value that is? Yes, that's your C value. So we know that C is 2. And we know that we have that foci equation. And it's subtraction because we're adding, right? Whenever we're adding here, we're subtracting in the foci equation. So if we're going to set it up, it's going to be C squared. Actually, let's just call that 4 for now, because then I don't have to simplify again. So C squared equals, and this one, it's always the bigger minus the smaller, and the 16 is going to be bigger than our b squared, right? So it's going to be 16 minus our b squared, and if you simplify that, take away 16, you get -12 equals -b squared, so divide by -1, and that means b squared is 12, and b squared is what we want. So we're just going to plug that 12 in right here. We don't need to square root it. We want it to be b squared, and that is your equation then. Okay. Okay, if you need a little break, pause it for a little bit, come back, because we still have a page and a half. It's not a short lesson. Okay, hyperbolas. We're switching gears here. This is hyperbolas that are centered at HK. So our two equations, remember we have two because it can open the left and right or up and down. So this is going to be, for the first one, it is x minus h squared over a squared, and now we're subtracting, minus, and then it's y minus k squared over b squared equals 1. Okay, so that's one of the equations. That's the one that opens left and right. So whenever x squared is first, it's opening left and right. Okay. The other equation, and it's because we're subtracting, right? When you subtract, there is no commutative property with subtraction. So you can't just switch the order and get the exact same thing. So when we switch the order, when we put the y minus k first, then that switches our graph as well. So it's y minus k squared over b squared minus x minus h squared, I'm running out of room here, over a squared equals 1. Sorry about the overlap. So that's our formula, and this is the one that opens up and down like this. Okay, so we're going to talk about those, do a couple examples here. Example 5 tells you to graph this hyperbola, and we need to find the center first. And again, just like the ellipses, the center is the opposite of what you see with your x and your y. So the center here is going to be -4, -1. Okay, so we're going to go -4, -1. That's going to be our center. Okay, now you have to ask yourself the question, which is first, okay? Our first is our x in this setup, right? The x comes before the y. So the x is what's going to give us our vertices. So the way we figure out where those vertices are, we take our x value, this 4, and square root it. That means we are going 2 to the left and to the right. Okay, so from that center, I'm going to go 2 to the left, put a point there, 2 to the right, put a point there. Okay, so those are my vertices. That would be the point -2, -1, and the point -6, -1. Okay, those are my vertices. So then from here, they ask you, what is your transverse axis length? And if you look at this length, we'll go here. 1, 2, 3, 4. Remember, it's the distance between your vertices. So our transverse axis length is 4. Okay, and let's graph this. Let's just finish graphing this now. So the way we figure out, remember this is the one where you have to do the rectangle. The way we figure out where that rectangle is going to go, let me get these guys out of here, is we need to use that 25. We're not going to put points there, but that's where it's going to guide us to, so this is 5 up and down. It's going to guide us to where our box should be. So 1, 2, 3, 4, 5. We're just going to put a little dash there. 1, 2, 3, 4, 5, a little dash there. And now we're going to make our rectangle. So the rectangle is going to go like this. Okay, and then we draw our asymptotes in. Our asymptotes would be here and here. So our graph, I'm going to do this in blue since my vertices are in blue. Our graph goes to those asymptotes, but not through them, like that, and like that. Okay, notice the x was first, and we opened up left and right. Okay, so the foci. We need to know a few things here. The foci is going to be a distance from the center, whatever C is. And we don't know C right now, but we do know A and B. So we're going to use the foci equation. Remember, when we are doing subtraction, then the foci equation uses addition. And it doesn't matter what order you add them in, a squared plus b squared or b squared plus a squared. It doesn't change anything. What we're going to do is we're going to say c squared is a squared plus b squared, or the square root of, well, c squared is 29. If we take the square root of that, we get that c is a positive or negative rad 29. Okay, now that doesn't simplify to a nicer radical at all. So we're going to use that as you see it. But we have to do this from the center. So think about what's happening here. If we're looking at the graph, okay, my foci are going to be somewhere over here and somewhere over here, which means that my x value is going to change from the center, but my y value isn't. My y value is still going to be -1. So what it's going to be is the x value of the center. Okay, so if you look up here to the center, it's still a -4, but we now have to either add rad 29 or subtract rad 29 from that. So that's going to be my new x value. And then my y value stays the same. It's still -1. Because it's still on that same axis, I guess you could call it. So that will be my foci, are those 2 points. -4 plus rad 29, -1, and then -4 minus rad 29, -1. Okay. All right, number 6. This one, first of all, this is not in standard form. The way we get it in standard form is we always want it to equal 1. So if I want this to equal 1, I need to divide everything by 36. So that by 36, this by 36, and this by 36. So what I get when I do that, I get y squared, notice the y is first this time, over 9, minus this. We can't simplify anything. X plus 4 squared over 36. That's going to stay that way. And then equals 36 divided by 36 is 1. So this is standard form. This is what we want to see. Now this problem looks a lot easier for us. So we're going to start by finding the center, and be careful because your y is first now. Okay. So notice there's nothing added or subtracted there, so your y value is going to be 0. That's this one, right? And your x value is going to be the opposite of that number, so -4. So our center is -4, 0. Okay, let's go ahead and plot that. -4, 0. Okay, so that's the center. And then our vertices go based on whatever is first. And this is first in our equation right now. So that means that my vertices are going to be the square root of 9. So up 3 and down 3 from that setup. So we're going to go up 3, 1, 2, 3. And we're going to go down 3, 1, 2, 3. Look just like that. Okay, so my vertices, if we name those points, are -4, 3, and -4, -3. Okay, and then we want our transverse axis length, and that would be the distance between my vertices. So that's 3 and 3, or a length of 6. Okay, and then let's just graph it right now. So for this one, we need to use this 36 and take the square root of it. That means I'm going to the left because this is my x. Okay, so I'm going to go left 6 and right 6. So left 6, 1, 2, 3, 4, 5, 6 is going to put us right at 10. Right 6, 1, 2, 3, 4, 5, 6 is going to put us at 2. So we're going to draw our rectangle. And then our asymptotes. Okay. So then if we graph this, our graph is going to look something like this. Okay. And the last thing we have to do is find our foci. And our foci, we have to use our c squared equals a squared plus b squared again. Okay, so our a and b are 9 and 36, so c squared equals, 36 plus 9 if we leave it in that order. So c squared equals 45. And then when we square root that, we need to put this into simplest radical. So rad 9 and rad 5 is 3 rad 5, okay? So our c is plus or minus 3 rad 5. So what we need to do is figure out, okay, well, if that's our c value, we need to go in the direction of our transverse axis, right? So I know my foci are going to be somewhere up here and somewhere down here. So my x value isn't changing for my center. So I'm still going to have a -4 x value, just like I did up here. But I need to add and subtract 3 rad 5 to my y value because I'm moving up and down. So it would be plus or minus 3 rad 5. Since we're adding it to 0, you don't have to put the 0 in front. You could, but you don't need to. Okay. All right, almost there. Number 7. This one says write the equation for a hyperbola with foci at 2, -3 and 2, 7. So what we're going to do is plot those points. Foci at 2, -3, okay, is right here. And then 2, 7, 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay. And then from here, okay, these are just our foci. Keep that in mind. This is foci for those. Sorry, I got loud kids going on in here. I don't know what I was just saying to you. Okay, these are foci, right? So if these are foci, we can still find the center because the center is going to be exactly in the middle of our foci. So our center, if you think about how far this is from 7 to -3, that's 10 units. So I need to go 5 units to get to the center. So 1, 2, 3, 4, 5 would be my center. And that point is 2, 2. Okay, so we have a center of 2, 2. And now we can set up our equation. You got to be careful here because our foci is up and down, which means that's our y value. So the y is actually coming first here. So it's going to be, and here's the other place you have to be a little bit careful. But in this case, even if you did it wrong, you'd get it right. This is your x, this is your y, right? We're going y minus, or we could call it our h and our k is probably a better way to think of it. That this goes with your x and with your y. So it'd be y minus 2 squared, and then it's minus, and then x minus 2 squared over something equals 1. Okay, so this is our setup. We have to figure out what information we have here. And it says we have a vertical transverse axis of 6 units. Well, if our transverse axis is 6 units, remember transverse axis is the distance between our vertices. So if it's 6 units long, we need to go 3 up, put a point there, that's one vertex. 1, 2, 3 down, put a point there, that's our other vertex. So that's 6 units long, right? Which means our B value, our up and down from center to vertex, this length right here, is going to be 3 units long. So if B is 3, that's going to go under our Y. That's a 3 squared, so this is going to be 9. Okay, then we also know right now this length, which is C for us, that is 5 units long. Okay, so we know C is 5, and we know our b value. So we're going to plug it into the foci equation. C squared equals a squared plus b squared. So it's going to be c squared would be 25 equals a squared plus, and then our b squared is 9. So take away that 9, and we get a squared is 16, which means that that 16 is going to go right here where our a squared goes. So our equation looks like that. Okay. Okay. Last thing, and this looks terribly confusing, but it's really fairly simple if you just know the different pieces to it. So just to be clear, P is a parabola, E is an ellipse, H is a hyperbola, and C is a circle. Okay, so it says identify each of the following as parabola, hyperbola, ellipse, or circle. And this tells you what these will be. So a parabola will only have one x squared or y squared in the whole thing. So if you look here, x squared and a y squared, x squared and a y squared, x squared and a y squared. The only one that has that is that first one. The third one. So this would be a parabola for letter C. Okay. Then if you look at an ellipse, this has an x squared plus y squared of different numbers. So both positive, but different numbers. Okay, and if you look at that, we have 5x squared and 2y squared, both positive, but different numbers. That makes this the ellipse. Okay. Third one, hyperbola. This means you have x squared minus y squared, or y squared minus x squared is fine too. So in other words, one is positive and one is negative. So positive 4y, negative 5x squared, that's going to be the hyperbola. Okay. And then the last one, the circle, you're going to have an x squared and a y squared that are the same numbers. With the circle, right, your radius is always the same distance. So you're going to go the same distance left and right, up and down, so you have the same value for both your x squared and your y squared. So when it looks like that, then we have a circle when these are the same. Okay, that's it. Sorry, it's a long one.